Hello students! Welcome to another fun of learning. Welcome to our quarter 4 science lesson, and I'm your grade 10 science teacher, Mrs. Marizoy Esca. Our lesson for today is about rates of chemical reaction. When you burn wood, heat is produced. We use this heat to cook our food or boil water. And the chemical reaction in this case is the burning of wood, and since heat is given off, we say that the reaction is exothermic. So we define an exothermic reaction as a reaction where heat is evolved or given off. When you mix urea and water, the container of the mixture feels cold. This is an example of endothermic reaction, and it is a reaction wherein heat is absorbed. And to represent exothermic reaction, the value of change in enthalpy or the delta H is negative. Enthalpy refers to heat content measured at constant pressure, while in endothermic reaction, to represent this reaction, the value is positive. Aside from being exothermic or endothermic, chemical reaction taking place around you are also sometimes very fast or very slow. Burning is very fast chemical reaction, while the rusting of iron is slow. If a certain chemical reaction is desirable or useful, like the production of drugs to cure diseases, we want the chemical reaction to happen fast, so we can produce more in a short period of time. Is there anything we can do to alter the rate or speed of chemical reaction? Did you know that firecracker expulsion is an example of exothermic reaction? A very fast exothermic reaction, and the speed or rate of chemical reaction is altered or changed by the following factors. The first factor affecting chemical reaction is the nature and size of the reactants. The particle size can increase or decrease the rate of reaction. One of the example of it is the grinding of calcium carbonate before calcining. The second factor is the concentration of the reactants. The rate of the reaction is also observed to be proportional to the concentration of the reacting system. This simply means that the greater the number of reacting components represent in a container, the more reaction will occur in a given time. And one of the example of it is the rusting of iron but not gold. The third factor is temperature. Temperature can either increase or decrease the rate of reaction. The spoiling of food indicates that an undesirable chemical reaction has taken place. During summer, foods are easily spoiled. To avoid spoilage, those are stored inside the refrigerator. And one of the example of it is spoiling of food at a warmer temperature. Factor is the presence of catalyst. If the desired reaction has to be carried out swiftly without elevating the temperature, catalysts are used. Catalysts are substances that alter the rate of chemical reaction without being consumed. It simply means that catalyst takes part in the reaction, but after the reaction has been completed, then can be recovered and used again. Catalysts alter the rate of reaction, and therefore this can increase or decrease the rate of a particular reaction. So when a catalyst increases the rate of chemical reaction, it's said to be a positive catalyst, or simply named catalyst. If it is slow down the reaction, it is called negative catalyst, or commonly called an inhibitor. How do catalysts accomplish this altering action? They do so by providing an alternative step or path for the reaction to occur. They make shortcuts to reach this destination. Catalysts can be of metals, ions, acid, or bases. Inside our body, we have catalysts. Those are called enzymes. Enzymes do amazing tasks like converting the food we eat to energy and maintaining and repairing our cells. Example of the presence of catalyst is the fermentation of sugar to alcohol using yeast, and the copper oxide is speed up to the decomposition of hydrogen peroxide. That's all for today, students. I hope you learn and enjoy our lesson for today. Till our next lesson, God bless us all.